Okay, welcome back. As I said, I ask you to answer these questions on your own. What is energy? Okay, energy is the ability to cause change or to do work. Okay, it happens when a force makes something move a distance. Okay, so we could either be adding kinetic energy to something, we could be adding potential energy to something. Okay, but it's the ability to cause change. 4 forms of energy that we talked about at the beginning of this unit and in the last video. Okay, potential is stored energy. Unless it is not moving and it's motionless, it's never all potential. Kinetic energy is energy in the form of motion. Nothing is, and I put in here just to remind you, nothing is ever just kinetic energy. This is part of the total due to its motion. So like when we looked at that pendulum, we would say, well, part of the total energy of the pendulum, part of that mechanical energy is due to its motion. So that's the kinetic part. Mechanical is the total potential energy of a system. It's all the parts that are added together. And then energy travels in waves is a form of energy in waves. It could be radiant like heat or mechanical like water and sound waves. What do you think the law of conservation of energy would state? Okay, use your prior knowledge. Now remember, all the laws of conservation say whatever it is, matter, energy, momentum, is not lost or gained, created or destroyed, but it can change form. So guess what? Energy is not lost or gained, created or destroyed, but energy can change form. So like we looked at the example with the pendulum, it can go from all potential to mechanical to kinetic at the bottom and back and forth. And the energy can be changing from one form to another, but it's not created or destroyed, lost or gained. Okay. Kinetic energy depends on mass and velocity. And energy is measured in joules, just like work was measured in joules, because work is a transfer of energy. Okay, in this section, we're going to talk about the 7 major types of energy. Okay, now we're going to review quickly the 4 forms of energy that we did in the last section. Okay, there's kinetic energy, there's potential energy, there's combinations of kinetic and potential energy, and there's wave energy. So combination of kinetic and potential energy usually is going to be mechanical energy. Okay, the first kind of form of energy that people use is chemical potential energy. And this is the energy that's stored in the chemical bonds between atoms. Okay, fuels like gasoline and food have stored chemical energy. So like during the process of photosynthesis that you learned about last year, the plant is out there in the sun. It's taking the energy from the sun, that radiant energy, and it's storing it in the glucose during photosynthesis. So that chemical potential energy has actually been added to the molecules of sugar. Now, when you eat the sugar and digest it, the reverse process happens and that energy is released into you, and you use that energy that came from the sun to be able to move around and keep your body warm. Okay. There's a lot of energy in the bonds between atoms waiting to be released. Same thing when you burn wood in the fireplace. That energy that came from photosynthesis was stored in the bonds, and the chemical bonds during photosynthesis as the tree grew. It's there being ready to be released. And then when you put it in the fireplace and burn it, the energy that came from the sun that was stored in the bonds is released, and then you see it in the form of heat and light during the fire. Now, this is also true with the fossil fuels that we use. Things like gasoline, natural gas, and coal. Those plants died millions of years ago, but that energy that came from the sun during photosynthesis was stored in those chemical bonds, and it's in the fuel waiting for us to use it in the form of gasoline and coal, oil, natural gas. Nuclear potential energy is the energy stored in the nucleus of an atom, and this is what holds the protons and neutrons together. Okay, when you separate the nucleus, a lot of energy is released. Okay, and this is nuclear fission is what we use. Now, also the same thing happens in reverse when atoms join together and they fuse, like on the sun, a great deal of energy is released. So this happens when atoms are split, like what happens in a power plant, or when atoms are fused together, like what happens on the sun. And then there's electrical energy, and this comes from moving electrical charges. Okay, this is the energy that's responsible for electricity. Electrons are not moving, there's no electricity. This is a form of kinetic energy. Mechanical energy, and we touched on this in the first lesson, mechanical energy is the energy that's the total of the potential and kinetic energy of a system. Remember, a system is a collection of parts that work as a whole, so like your body or an airplane or a car. So it's the whole thing working together as one big unit. So like I put in here all the parts of a bicycle, create a system of the bicycle. Okay, it includes the moving parts, which is the kinetic energy of the system, and also the non-moving parts, which is the potential. Okay. Thermal energy comes from the potential and kinetic energy of the atoms and molecules of a substance. So remember, in the kinetic theory last year, we said those atoms and molecules are constantly moving. The faster they move, the more thermal energy they have. And so we said in the unit on phase change, the faster they move faster and faster and faster. And then eventually they broke apart because they had gained so much energy and so much kinetic energy that they broke the bonds and changed phase. Okay, and as they move faster and faster, that's because they're storing thermal energy, okay, or thermal energy is being added to them, okay? So it's energy that comes from the motion of the atoms and molecules. Okay? So total energy of the atoms and molecules, and it also depends on how much of the substance there is. So like an example would be like if you had a cup of water that was 100 degrees, if you had, which is boiling in Celsius, or if you had a 5-gallon bucket, the 5-gallon bucket of water that was at 100 degrees or boiling would have more thermal energy in it because it would have more atoms and molecules moving at that same average speed. And there's electromagnetic energy, which is often called radiant energy because it moves in rays or waves. Okay, it's energy that comes from electromagnetic waves. Okay, and it has characteristics of being partly electrical and partly magnetic. Okay. And so these things, examples, visible light, UV rays, microwaves, radio waves, are all part of what's called the electromagnetic spectrum. So I'm going to take a look at the electromagnetic spectrum. It goes from really big waves like radio waves, okay, and then micro is really just small radio waves. That's what it meant, small radio waves. And then infra means below red. So this is just below red light that we can see. And usually we think of infrared as being heat. So you have this visible spectrum that goes from red to violet, and the wavelength just below red is called, that's what infra means, below red. So it's right here, and this is heat. So when the military uses night vision goggles, what they're doing is the goggles adjust this wavelength and bump it up so that it becomes visible. And the last thing that we can see is violet light. And then just above violet is, it means ultra, which is above violet. So the first wavelength above violet is ultraviolet. So when you put things in a black light, what it does is it's reflecting the ultraviolet light. And when it does that, it makes it so that we can see it. And then above ultraviolet light are X-rays, and then moving faster with even more energy are gamma rays. Okay, and then this place in between is where we have visible light. Okay, it's right here, and it goes from red to violet, and as the wavelengths decrease and they get shorter and shorter and higher in frequency, the waves have more energy and they become actually more dangerous to us. So if you think like you can get sunburned from ultraviolet light, X-rays are dangerous. That's why they cover you with that sheet when you go to get one. Gamma radiation is what comes from nuclear radiation and is very dangerous. Okay, so we're gonna leave off here. I'd like you guys to answer these questions on your own. And when we come back next time, we'll pick up here. I hope you're having a great day, and we'll see you next time.